Okay folks, I thought I'd work through questions 8, 9 and 10 of reacting mass calculations 1 with you, for those of you that are still struggling with this concept. I haven't got the instructions on the board because I'm working in a different building today, but again it's exactly the same process. So I'm just going to go through the question. What mass of calcium carbonate is needed to remove 1 tonne of sulphur dioxide? And we'll come on to what we need to do with that 1 tonne in a moment. So again, first thing is identify your question mark. So what mass of calcium carbonate, so which of these things here do you think is calcium carbonate? There is no formula, so you're going to have to try to work it out. Well, calcium means it contains calcium, so it's either going to be that one or that one. Carbonate means it's got carbon and oxygen in it, which means there is my question mark. And we're removing 1 tonne of sulphur dioxide. And there's a couple of things you can do here. You can convert that into grams, all right, which would be 1,000,000 grams, or you could do the calculation for 1 gram. And if you do it for 1 gram, okay, you can then just erase the grams and put the word tonne at the end. So there's a couple of ways of doing it. I'm going to try it that way, I think. So we're removing 1 tonne of sulphur dioxide. So sulphur dioxide, sulphur S, dioxide means 2 oxygens. So I'm going to put 1 gram, even though I know in reality it's 1 tonne. So I'm going to set my grid up. So I'm starting here, going this way now, and back up to there. So first things first, so mass into moles is divide by MR, and then it will be times MR over here, and the ratio, look, is 2 to 2, or 1 to 1. So whatever number I get there, I just have to transfer to there. And before I start, I'm going to make sure I can calculate the MRs correctly. So sulphur dioxide, SO2, is 1 times S and 2 times O. And using your relative masses at the top of your worksheet, I know that that is 1 times 32, which is 32, 2 times 16, which is 32, add them together is 64. So I know the MR there is 64. And the same thing for calcium carbonate. So calcium carbonate over here, CaCO3, it's 1 Ca, 1 C, 3 O's, 40, 12, 3 times 16 is 48. Add them together, should equal 100. And then, even if I've made a mistake now, as long as I carry through that mistake towards the end, I can still get quite a few marks on these calculations. So let's have a go. So the first step, 1 divided by 64 is 0.0156 moles. And because it's a 2 to 2 ratio, or 1 to 1, whatever number's there, the same as the number here. And then the final step, up here, times by the MR, which is 100, and you end up with 1.56 grams. So, if I needed 1 gram of sulphur dioxide removed, I would need 1.56 grams of calcium carbonate. But the question was about tonnes, so what I'm going to do is swap the G's for tonnes. And there you go. Okay, so I'll work through the questions 9 and 10 in a minute, so if you'd like to pause the video and have a go at those, and I'll go through the answers in a second. Okay, folks, here's question 9. What mass of potassium oxide is formed when 7.8 grams of potassium is burned? All right, so again, I'll do exactly the same as before. Identify the question mark first. So what mass of potassium oxide is formed? So potassium oxide must have potassium and oxygen in it. So it must be that one there. Is formed when 7.8 grams of potassium is burned. So it must have potassium in it. It can't be that. So it must be pure potassium, which is over here. Right? And again, I'm going to set out my grid exactly the same way. So I'm starting here, and I'm going to end up over there. So that'll be divide by the MR. The ratio now is 4 to 2, or 2 to 1, and we'll explain what to do with that in a moment. And then times by the MR, over here. And then just before I start, I'm going to have a go calculate the MRs of these things correctly first. And if I do make a mistake, as I said before, you'll get error carried forward. So the MR of potassium, if you look at the top of the sheet, is 39. The MR of potassium oxide is, well, let's just work this out, 2 times potassium, 1 times oxygen. So they add together to make 94. Yeah. And now I've got everything set in place, ready to go. All right. The ratio is 4 to 2 or 2 to 1, which means that the number on this side will be twice as big as the number on this side. So what I'll have to do is whatever number I get here, I'll have to halve it to get the number there. All right. Let's have a go. So 7.8 divided by 39 equals 0.2 moles. And again, because it's a 2 to 1 ratio, so 2 to 1, right, this number here must be half that number there. So that would be 0.1 moles. And then the final step, times by the MR, which is 94. So 0.1. And you end up with 9.4 grams. So again, it's the same method as before. Hopefully you're getting more and more confident with these. I'll try the last question, I'll try question 10 in a moment, and then hopefully you guys can have a go at reacting masses calculations too, all right, on your own. Okay. Okay folks, last one for this video. It's question 10 on reacting mass calculations 1. What mass of oxygen is required to oxidise 34 grams of ammonia to nitrogen monoxide? So again, read the question carefully, follow through the 5 steps that we've talked about so far on these videos. So the question mark, what mass of oxygen? So that's what I'm trying to figure out. What is the oxygen in this particular equation? Well, oxygen is just O2, so it must be that. So there's my finish line. Where am I starting from? So, required to oxidise 34 grams of ammonia. So, ammonia tells us NH3. So, it's that there. Right. And again, I'm going to set up my grid as before. Divide by NR, times by MR. And the ratio is 4 to 5. Oof, I haven't had that ratio before, so we'll discuss what to do with that in a moment. So let's get the MR sorted. So NH3 is 1N, 3 H's. So that's 17, so the MR is 17. And O2 is 2 lots of O, which is 32. And again, even if I've made a mistake, I'll get error carried forward. So, everything's now set up. We'll discuss what to do with the ratio when we get there. So, first step, 34 divided by 17 is 2 moles. Now, the ratio here is 4 to 5. Yep, so 4 to 5. So, how do we go about doing that conversion? All right, so, easiest way to do it is if you divide by 4 first and then multiply by 5. Yep, so I'm going to take 2, divide by 4, times by 5, and you end up with 2.5. Yep. And then once I've got 2.5, I just times by the MR, which is 32, and you get 80 grams. So again, that takes you through the first 10 questions of that worksheet. The 11th question is a really, really challenging question, so have a go at that if you want to, but if you get stuck with that, don't worry about it, just move straight on to reacting mass calculations too. Right? Hope these videos have helped you to get to grips with these calculations, and I hope you had a lot of fun doing them.